Hi, good day sir. I'm Chris Justin Esasido and I'm excited to show you my mobile app. My app is a jersey identifier for basketball jerseys. Basically, it can detect jerseys from 10 NBA teams, including Boston Celtics, Brooklyn Nets, Chicago Bulls, Dallas Mavericks, Denver Nuggets, Golden State Warriors, Los Angeles Lakers, Miami Heat, Milwaukee Bucks, and Phoenix Suns. How the app works. First, the Detect tab. When you open the app, it goes straight to the Detect section. Here, you can pick a jersey you want to detect. Let's say you choose Boston Celtics. The camera will open ready to detect. If the camera sees something that doesn't match your selection, it will show an error. But if it detects the correct jersey, you'll see the detection result. This includes confidence level. Confidence level, how sure the app is about the jersey. And class probabilities. For example, Boston Celtics detected with 100% confidence. You can also confirm the result to mark it as verified. This helps the system improve over time by collecting accurate data. And if you want, you can retake the detection or check the confusion matrix, which shows how well the app performs by comparing the correct jersey to the predictions. You can filter it by all, verified, or not verified. And there's a small question mark icon to explain everything. Next, the History tab. Here, you'll see the full detection history, including both correct detection and errors. For example, if you select a Boston Celtics but detect a Brooklyn Nets jersey, it will be saved as an error. You can export this data as JSON or CSV, which includes all the history records. Individual history items can be deleted, or you can clear all history at once. You can also filter history by verification status, result, team, or class, or date range. So for example, you could view all verified correct Boston Celtic detection in a certain date range. Finally, the Analytics tab. The dashboard gives you a complete overview of the app performance. You can filter by all detection, verified, not verified, or errors only. Key metrics include total detections, overall accuracy, verification rate, and error rate. It also shows latest 7 days daily activity, blue for detection, and green for accuracy. Per class performance, it will show total detection and accuracy per jersey. If you turn on errors only, it will display total detections, total errors, verification rate, error rate, and daily error trends. Red for errors, orange for error rate. In the hardest jersey, it highlights the jerseys that are most often misclassified. And that's the full flow of the app. Thank you so much for your time and I hope you enjoyed seeing how it works.
What challenges did you encounter when exporting the train model? And how did you integrate it into your Flutter application?
The main challenge was making sure the TensorFlow Lite model worked correctly in Flutter. The model and labels were stored in the assets folder and loaded when needed. I also had to pre-process images to match the required input size before running the model, and ensure the labels matched the model output.
How did you ensure that the homepage layout remains responsive across different screen sizes?
I ensured responsiveness by using Flutter flexible layout widgets like Grid View, Expanded, Flexible, and Media Query. These allow the user interface to automatically adjust the different screen sizes while keeping consistent spacing and proportions.
What part of the project did you find most technically challenging, and how did you overcome it?
The most challenging part was real-time camera detection with good performance. I handled this by optimizing image processing, reduce unnecessary model calls, and running heavy tasks in the background to keep the app smooth.